Alright, so in this problem, I have 4 to the power of x plus 4 to the power of x plus 4 to the power of x plus 4 to the power of x is equal to 1. So to solve this, the first thing I'm going to do is I'm going to factor out 4 to the power of x from my left-hand side. So now I have 4 to the power of x times, now 4 to the power of x divided by 4 to the power of x is 1, so I have 4 to the power of x times 1 plus 1 plus 1 plus 1, and this is equal to 1. Now 1 plus 1 plus 1 plus 1 is simply equal to 4. So now I have 4 to the power of x times 4 is equal to 1. Now, 4 here, that's the same thing as 4 to the power of 1. And if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 4 to the power of x times 4 to the power of 1, that's going to equal 4 to the power of x plus 1. Simply just add these two exponents. And this is equal to 1. Now, anything to the power of 0 is simply equal to 1. So I can simply replace 1 here with 4 to the power of 0. And the reason I did that was to make these two bases the same. So now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So I simply just set the exponents equal to each other. So I have x plus 1 is equal to 0, and this is a simple equation. All I have to do is subtract 1 on both sides. These two cancel out, and I'll be left with x is equal to negative 1. Now, I actually have a second method of solving this problem. So again, we first start with 4 to the power of x plus 4 to the power of x plus 4 to the power of x plus 4 to the power of x is equal to 1. Now again, I'm going to factor out 4 to the power of x, so I get 4 to the power of x times 1 plus 1 plus 1 plus 1 is equal to 1. Now if I simplify it in parentheses, I get 4 to the power of x times 4 is equal to 1. Now this time, instead of multiplying these two, I'm simply going to divide both sides by 4. So then these two cancel out, and I'll be left with 4 to the power of x is equal to 1 over 4. Now, if I have something in the form 1 over a, this is the same thing as a to the power of negative 1. So 1 over 4, that's going to equal 4 to the power of negative 1. And now, since these two are equal to each other, the exponents are equal to each other as well. So I'm left with x is equal to negative 1 again. So that's two ways of solving this equation. All right, so in this problem, I have 2 to the power of 18 minus 16. So to solve this, I'm going to first rewrite 2 to the power of 18 as 2 to the power of 9 times 2. So now I have 2 to the power of 9 times 2 minus 16, which I can rewrite as 4 to the power of 2. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 9 times 2, I can rewrite as 2 to the power of 9 to the power of 2. Now I have this minus 4 to the power of 2. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, I can think of a as 2 to the power of 9 and b as 4. So now I have 2 to the power of 9 plus 4 times 2 to the power of 9 minus 4. Now, if you guys already didn't know, 2 to the power of 9, that's equal to 512. So now I have 512 plus 4 times 512 minus 4. 512 plus 4, that's 516. 512 minus 4 is 508. So I have 516 times 508. Now from here, what I'm going to do is I'm going to rewrite 516 as 500 plus 16. And I'm going to rewrite 508 as 500 plus 8. So the reason I did this was to make this problem easier to multiply, because we're trying not to use a calculator, and if we multiplied 516 with 508 on paper, that's going to take a while to solve. So now all I have to do is simply distribute 500 first. So I get 500 times 8 plus 500 squared. Now I'm going to distribute the 16, so I get 16 times 500 plus 16 times 8. Now let's go ahead and simplify this. 500 times 8, that's 4,000. 16 times 500 is 8,000. Now 500 squared, and that's going to be 50,000. And 16 times 8, that's simply equal to 128. So I have 4,000 plus 8,000 plus 50,000 plus 128. 4,000 plus 8,000 is 12,000. 12,000 plus 50,000 is 62,000. And 62,000 plus 128 is 62,128. So this is my answer. Alright, so in this problem, I have 0.01 to the power of x is equal to 2. So I want to find the value of x here. So for my solution, first start with 0.01 to the power of x is equal to 2. Now I'm going to take the log on both sides. So now I have log 0.01 to the power of x is equal to log 2. Now if I have something in the form log a to the power of b, I can simply move this exponent b to the front. So this would equal b times log a. So in this case, I have log 0.01 to the power of x, and I can simply move x to the front. So that's going to equal x times log 0.01 is equal to log 2. Now 0.01 is the same thing as 1 over 100. So now I have x times log 1 over 100 is equal to log 2. Now if I have something in the form log a over b, this is equal to log a minus log b. So in this case, I have log 1 over 100. I can rewrite this as log x times log 1 minus log 100. This is equal to log 2. So now, log 1 simply equal to 0, and log 100 is simply equal to 2. So I have x times 0 minus 2 is equal to log 2. That's equal to approximately 0.301. Now 0 minus 2 is negative 2, so I have negative 2 times x is equal to 0.301. And now I'm going to go ahead and divide both sides by negative 2. So these two cancel out, and I'm left with x is equal to 0.301 over negative 2, which is equal to negative 0.1505. So this is my answer.